In this problem, we're asked to evaluate the sum of an infinite series, and it's the sum from n equals 1 to infinity of the quantity 1 over n plus 2 minus 1 over the quantity n plus 3. The way we evaluate this type of sum, an infinite sum, is that we first figure out a formula for the partial sums. That's what the S sub n is, the form of a partial sum. And then we take the limit as n goes to infinity. The partial sums, as the name suggests, are a sum of part of the series, the part that starts at I equals 1, and then summing up to I equals n. Here, we're going to replace a sub I with the form of the terms in our series, but we're going to replace each of the n's by I. That gives us this expression right here. And now what we need to do is figure out which of these terms are going to cancel and what terms remain after they cancel. And to do that, it's going to be helpful to first distribute the sum so that it's affecting both of the terms separately. So just distributing the summation to both the terms, we get this expression. And now, in the first sum, I have 1 over I plus 2. In the second sum, I have 1 over I plus 3. I am going to change these sums so that they have the same form for their terms. Instead of having I plus 2 and I plus 3 different forms for the different terms, I'm going to make them both into 1 over I. When I do that, I will need to change the limits of the sum because, for example, this first sum, if I had plugged in I equals 1, then I would have ended up with a 3 in the denominator. So the first term in this sum should be I equals 3. Similarly, the last term in this sum would have been when I plugged in I equals n, which gives n plus 2. So the sum should end at n plus 2. Need to change the limits of the sum for the second term as well. Here, when I plug in I equals 1, the first term would have started with a 4 in the denominator. So I'll start with I equals 4. And if I plug in I equals n, I get n plus 3. So the sum ends at n plus 3. Now I need to figure out which of the terms are going to cancel from these two sums. The way that I'm going to do that is I'm going to rewrite these sums in a certain way. The first sum, I'm going to write it so that instead of starting from I equals 3, it's going to start from I equals 4. But I can't just drop the first term, the term associated with I equals 3, so I write that out separately. So the first term was 1 over 3, I have that written out, and then I have the rest of the sum written using the summation notation. Then I do something similar for the second sum. It went from I equals 4 to I equals n plus 3. I want it to have the same limits as this other sum, so I want it to end at n plus 2. But if I'm going to do that, this sum ended with n plus 3, with I equals n plus 3, and so I need to pull out the I equals n plus 3 case from this other sum. So that's where this comes from. Now that we've done this, the parts that are written using summation notation are exactly the same, and they're being subtracted from each other. And so they are just going to cancel, and the only things that remain are 1 over 3 minus 1 over n plus 3. What we have found so far is an expression for the partial sum S sub n. To finish evaluating the sum of the series, we need to take the limit of this expression as n goes to infinity. That's the last step in this problem. Taking the limit as n goes to infinity in this case is quite easy. The limit of a constant is just a constant, and if you make n go to infinity, the second term is going to 0 because the denominator is getting huge. So the result of this limit, and therefore the result of the sum, is 1 over 3. This series that we were looking at does converge, and it converges to the value 1/3.